Take a look at this small common river pebble. It feels light in your hand, right? But if you drop it into the water, plop. It sinks straight to the bottom without hesitation. Now look at this, a massive steel container ship weighing hundreds of thousands of tons, floating perfectly. Wait a minute, a tiny stone sinks, but a giant iron ship floats? That doesn't seem to make any sense. Why does heavy steel stay on top while a light pebble drops like a rock? Let's solve this mystery. Whenever an object is placed in water, an invisible science magic happens. Water pushes back up against the object. We call this upward force buoyancy. To understand it, think about what happens when you jump into a full bathtub. The water overflows, right? Because your body pushes that water out of the way, displacing it. And here is Archimedes' golden rule. The upward buoyancy force is exactly equal to the weight of the water that was pushed away. So why does our little pebble fail this test? It's all about a battle of forces. Because the pebble is so small, it only pushes away a tiny insignificant splash of water. This means the upward buoyancy force is very weak, way too weak to fight the pebble's actual weight pulling it down. Scientifically, the pebble has high density. Its matter is packed so tightly together that it weighs more than the small amount of water it displaces. But what about steel? If you take a solid block of iron, it sinks just like the stone. The secret of the ship is its shape. Shipbuilders don't just throw a block of metal into the ocean, they hollow it out. Inside that massive steel hull, there's an incredible amount of empty space filled with nothing but light air. Because the shape is so wide and hollow, when the ship enters the ocean, it pushes away a colossal, mind-boggling volume of water. Remember the rule? More displaced water means a much bigger, stronger upward buoyancy force. The weight of the displaced ocean water becomes so gigantic that it easily matches the entire weight of the heavy steel ship. Gravity pulls down, but buoyancy pushes up with equal strength. It's a perfect tie, so the ship floats. By adding all that air inside, the average density of the entire ship becomes much lower than the density of water. Still hard to believe. You can test this at home right now with a simple piece of modeling clay. If you roll the clay into a tight solid ball and drop it in, down it goes. It sinks instantly. But take that exact same piece of clay, flatten it out and shape it into a wide hollow boat. Look at that, it floats. Same weight, but a different shape. Shape changes how much water you can push away, and that changes everything. So to wrap it up, the pebble is dense and displaces too little water, so gravity wins and it sinks. But the giant ship is hollow, displacing a massive ocean of water, making buoyancy win so it floats. Science isn't just about how heavy you are, it's about how you use your space. Change your shape, change your force. Thanks for watching, and see you in the next scientific adventure. Bye!